So there are a number of important distinctions to make between different forms of human genetic modification, which often get blurred. So the first of these is somatic genetic modification versus germline genetic modification. So somatic genetic modification, also known as gene therapy, alters the genetic sequences of an existing person's non-reproductive cells in order to treat an existing medical condition. So a major concern about this is ensuring that the procedures are safe, effective, and accessible. Earlier attempts at gene therapy using older genetic modification techniques were largely unsuccessful. And in the well-known case of 19-year-old American Jesse Gelsinger, caused an unnecessary death. More recently, however, there's been a number of important successes in somatic gene therapy, which have successfully treated individuals with a number of conditions, including beta thalassemia and hemophilia, and in a few cases have cured people of leukemia and sickle cell anemia. So by contrast, germline genetic modification refers to genetic interventions in human reproductive cells or embryos. And this poses unique ethical questions because unlike therapy, germline changes would be inherited for generations to come if used for reproduction. So it thus has to grapple with how these changes would affect not only the children immediately concerned, but all of their children's children as well, since it's irreversible. So the prospect of using human germline modification for the purpose of controlling which traits are passed down to future generations has long raised major concerns worldwide. So foremost among these concerns are that 1, this would have unalterable and largely unpredictable biological effects on resulting children and their offspring, and 2, that it would have disastrous social consequences if, as many believe, engineering genes thought of as quote-unquote superior would exacerbate existing forms of inequality and discrimination, something I will come back to a bit later. A second often overlooked distinction is the different ways that human germline modification can be used for research or for reproduction. So human germline modification for research, of course, does not result in pregnancy, and it's being currently undertaken in only a few countries, among them Sweden, the UK, and China. And the primary focus of this type of research at the moment has been on knocking out genes or getting rid of particular genes in order to see how that affects human development, human embryonic development. And by contrast, human germline modification for reproduction, again, has to account for the future generations that will be affected by this. And so that is then using a genetically altered embryo to initiate a pregnancy, affecting all future generations' genes. And this particular form is outlawed in more than 40 countries worldwide. So these crucial distinctions between somatic and germline modification and between germline modification for research and for reproduction are often confused in the media. In a recent Newsweek cover story titled Gene Genie, scientists can edit your DNA to cure what ails you unless you live in America. Author Madhumita Murugya begins with the successful story of Leah Richards, the first person to be cured of leukemia through gene editing in the UK. She's about 2 years old. But even though starting with this story, Richards is not the main focus of the story, and it quickly switches its focus to gene editing in human embryos. So for the casual reader reading this story, there's no distinction between these two made. And in light of the well-established fact that the media serves as a crucial broker between science and the public, influentially framing public consciousness around scientific issues, this confusion is very problematic. And it could lead some who wish to avail of the medical benefits of somatic gene therapy to think that they would also have to accept germline modification as well.